All right, now I'm verifying this identity. Tangent of theta equals 1 minus the cosine 2 theta divided by sine 2 theta. So what do I want to do? I want to use, because this does not have double angles and this does, I want to use the double angle identity. So I'm going to use 1 minus. Now one option I have here is using cosine squared theta minus sine squared theta. I can use basically any of them. But down below, sine 2 theta, that's 2 sine theta cosine theta. Now, I have all these options for cosine squared minus sine squared. So if if I'm looking at this, I'm like, well, which one of these versions of cosine 2 theta do I use? You got to think about your end goal. What do you want this to be? Now think about tangent. Remember, you can manipulate either side of the equals, but tangent is sine theta over cosine theta. Okay, so I want a sine to remain and I want a cosine to remain on the bottom. So what does it make sense to use here? Which one of these versions of this thing does it make sense to use here? The one that I want to use is not this one, because I want a sine to remain and I want just a cosine down below. That means I want a sine down here to cancel. So what do I want to use? I want to use the one that has only sines, so I can get this sine down here to cancel. I don't want a cosine. So I'm going to go back and switch this. Instead of using this version of this, I want to use the one that has only sines, which is going to be the one that has 1 minus 2 sine squared. So I'm going to rewrite this as 1 minus 2 sine squared. All right, that's the same thing as cosine 2 theta as well. And then notice what's going to happen when I distribute this through. I'm going to end up with 1 minus 1 is 0. Negative minus negative is a positive 2 sine squared theta. And on the bottom, I've got 2 sine theta cosine theta. So what's going to happen here? The 2's cancel. A sine cancels with a sine square. And I'm left with sine theta over cosine theta, which is the same thing as this. All right, you can finish it off by just writing that as tangent. Okay, so the importance of this example is that this, remember, the cosine 2 theta has multiple ways that it can be interpreted, or we can work around it. And it's your goal. What do you want? What are you trying to show when you're verifying an identity? Will determine which one of those that we ultimately use. I have 3 options that I can use here. Why did I pick this one? Because it makes the work easier to show what I'm wanting to show on the other side.